Hello everyone, welcome second year students English section, Faculty of Commerce at City University. This is Reem Sobhi. I'm a teaching assistant at Insurance Mathematics and Statistics Department. I will be with you in sections of Mathematics of Finance, Part 2, Compound Interest. In this section, we will discuss Chapter 7 titled Forborne Annuities. First, let's define forborne annuity. What do we mean by forborne one? The forborne annuity is a series of equal payments made at the beginning or at the end of each period, either annually, semi-annually, monthly, weekly, and so on, and earn interest for 2 or more periods after the last payment. So, the forborne annuities are a series of equal payments made either at the beginning or at the end, but may or earn interests for 2 or more periods after the last payment is made. We can draw this type. So this is 0, and this is the first payment, the second one, the third one, and so on until we reach the last payment. So this is the last payment, and we have here the period that the annuities earns interest for this period. So the last payment lasts for a period and earns interest, and we want to know the future value at the end of these periods, which is the so the forborne annuities affect the future value of the annuities only, not the present value. So the future value of a forborne annuities, we have two types of forborne annuities, ordinary one and due. The future value of the ordinary forborne annuity equals to Sn forborne equals R times 1 plus I power n minus 1 over I times 1 plus I power b. And the future value of a forborne annuity due equals to R times 1 plus I power n minus 1 over I times 1 plus I times 1 plus I to the power b. So this is the formula of the ordinary forborne annuity, and this is the formula of the future value of the forborne annuity due. Let's take some examples. Example 1, payments of $1,100 is made at the beginning of each year. So in this example, the payments, which is R and equals to $1,500, is made at the beginning of each year. So this is a due annuity, not ordinary. And these payments are made for 5 years, and it's an annual annuity. So M equals to 1 and N equals to 5. What is the future value of these payments if they accumulated for 7 years and the interest rate is 6% compounded annually? So the accumulation period equals to 7 years. So B equals to 7. B is the number of the accumulation period. Or number of periods of the for the accumulation, and the interest rate equals to 6%, which is J, and compounded annually. So J equals to 6% and M equals to 1, and I is J over M, so this equals to 6% also. N equals to 5, F equals to B equals to 7. And this annuity is an annuity due, but forborne one. So we will use the formula of the forborne annuity due, which equals to R times 1 plus I power n minus 1 over I times 1 plus I times 1 plus I power b. By substituting the values of R, N, I, and B in this formula, we get the future value of these payments, which equals to this amount. Another example, an annuity due of $2,000, so this is R, is made each 6 months for 5 years. So M equals to 2, as the payment is made every 6 months, so twice a year, so M equals to 2. And this for 5 years, so N equals to 5 times 2, which equals to 10. In a bank that pays 8 interest converted semi-annually, so J equals to 8% and I equals to J over M. What is the future value of these payments if they accumulated for 9 years? So J equals to 8%, M equals to 2, I, J over M, 8% over 2 equals 4%, and 10 equals to 10. B here equals to 9, as the accumulation period equals to 9 years. B here equals to 18, not 9, as the accumulation period equals to 9 years and M is equals to 2, so the B equals to 18. By substituting these amounts in the formula of the forborne annuity due, which equals to R times 1 plus I power n minus 1 over I times 1 plus I times 1 plus I power b, and this equals to this amount. This is the future value of these payments or these annuities. Another example, a man deposits $1,200 at the beginning of each month for 2 years in a bank that pays 12% compounded monthly. So the man deposits $1,200, so this is R, and this is made at the beginning of each month, so this is a due annuity, as it's made at the beginning of each month, and each month means M equals to 12. For 2 years, this would last for 2 years, so N equals to 2 years times 12, so N equals to 24. In a bank pays 12% compounded monthly, so J equals to 12% and I equals to J over M. What is the future value of these payments if they accumulated for 5 years? So the accumulation period here is 5 years, and B equals to 5 years times 12 equals to 60. So again from this example we get J 12%, M 12 months, I 12% over 12 months equals 1%. Sorry, this is 1% only, and N equals to 24, B equals to 60. As this annuity is a forborne annuity due, so we will use the formula of the future value of the forborne annuity due, and by substituting these quantities in this formula we get the future value of these payments. Another example, find the future value of the payments in the previous example if the payments are ordinary annuities. Again, he wants you to resolve or answer the previous example, but assuming that the annuities are due, not are ordinary, not due. So we will use the formula of the future value of a forborne ordinary annuities, which equals to R times 1 plus I power n minus 1 over I times 1 plus I power b. And again, j equals to 12, m 12%, m 12 months, and I 1%, n equals to 24, and b equals to 60, and r equals to $1,200. By substituting these values in the formula of the future value of the forborne ordinary annuity, we get the future value of these annuities. Example 5. A person plans to have $100,000 in his account after retiring in 25 years. If the bank pays 10% compounded monthly, how much does he need to deposit in his saving account at the beginning of each month for 20 years to achieve his retirement goal? So this man wants or plans to have $100,000 in his account after 25 years. So this is the future value, not the periodic payment, or not the annuity, or not the installments. This after 25 years, so the whole period equals to 25 years. The bank pays 10%, so this is J, which is compounded monthly, so I equals to J over M, and M equals to 12. The question here is how much does he need to deposit in his saving account at the beginning of each month. So at the beginning means this annuity would be an annuity due for 20 years. So N equals to 20 times 12, and this equals to 240 payments, and the accumulation period equals to 5. The accumulation period equals to 5 years, as the man would still deposit in his account only for 20 years, and he wants to have $100,000 after 25. So this is an accumulation period equals to 5 years, and B equals to 5 times 12 equals to 60. So J is 10%, M is 12, I is J over M, and N equals to 20 years times 12, 24, 240 periods or payments. B, which is the accumulation periods, equals to 65 years times 12. So 5 years and 20 years equals to 25, which is the whole period. And these annuities are a forborne annuity due, so we will use the formula of the future value of the forborne annuity due, which equals to R times 1 plus I power n minus 1 over I times 1 plus I times 1 plus I power p. By substituting the values of these quantities in this formula, we get these amounts. So we need to know the R, which is the periodic payments or the annuities. So by dividing these sides, or the left hand side by the right hand side, we get R, which equals to these amounts. Another example, find the future value of the payments in the previous example, but assuming that the payments are ordinary, not due one. So we will use the formula of the forborne, the future value of the forborne ordinary annuities, which equals to this quantity. And by substituting the value of this of R and S, N, I, and B, we get that By dividing the left hand side by the right hand side, we get the value of R. Another example given SN forborne. So this is the future value if forborne forborne annuity due, as this is the shape or the abbreviation of the annuity due, and this is a forborne one, which is abbreviation again also for the forborne annuity. R equals to 1000, N equals to 8, M equals to 1, B equals to 4, and he needs that to find I and J. So let's start with I first, and then we will find J. By using the formula of the forborne, the future value of a forborne or annuity due, which equals to Sn equals to R, Sn forborne equals to R times 1 plus I power n minus 1 over I times 1 plus I times 1 plus I power b. Sn forborne equals to 8,750, R equals to 1,000, 1 plus I, we don't have I, and this we want to find. N equals to 8 minus 1 over I times 1 plus I, 1 plus I power 4. By dividing this amount by 1,000, we get 8.75. And again, by using the same way, multiplying 1 plus I times 1 plus I, we have the same bases here, so we will add the power. So the power of this base is 1, and the power of this base is 4, so 1 plus 4 equals 5. This quantity would equals 1 plus I power 5. Multiplying this quantity once by 1 plus I power 8, and again the same base and different powers, so we will add the power. 8 plus 5 equals to 13, so 1 plus I power 13 minus 1 times 1 plus I power 5 over I. By using the trial and error method to expect the periodic rate I, we can say that it may lies between 1% and 2%. By substituting with 1% once, we get this amount, and by substituting with 2%, we get this amount. You can see here that 8.75 lies between these two values. So by dividing the difference between the internals over the externals, this is the internals, the difference between these internals, 8.75 minus 8.7083 equals I minus 1. So these are the internals over the externals, which are these values. So these the externals. By finding the quantity of this side, or the amount of this side, and multiplying this quantity times the difference between 2% minus 1%, which is 1%, this gives us I equals to 0.01054. And in order to check the answer, we can substitute the value of I in this formula, so or in this equation, so we can get 8.748, which approximately equals to 8.75. And this is so I equals to 0.01054, and M equals to 1. So J equals to I times M, and this equals to 1%, 0.054%. This is J. Another example given the future value of a forborne ordinary annuity, which is equal to $70,000, and R equal to 750, I equals to 6%, M equals 2, B equals 4. And the question here is how many full payments are there? So we need to find N. And these by using the formula of the future value of the forborne ordinary annuity, which equals to R times 1 plus I power n minus 1 over I times 1 plus I power b. By substituting these quantities in this formula, we get $70,000 equals 750 times 1 plus I, which is 6%, power n, we don't know n, so we need to find n, minus 1 over I times 1 plus I over power 5. So by dividing 70,000 over 750 times 1 power 4, this equals to this amount, and this equals to the remaining quantity in this side of the equation, which equals to 1 plus I power n minus 1 over I. So by multiplying these sides by each other, we get 1 plus I 0.6 power n equals to this quantity. So we have to take the logarithm for both sides in order to find the value of n. So this means n log 1.06 equals to log this quantity. So by dividing the logarithm of this of the right hand side of the equation by the logarithm of 1.06 gives us the n, or the value of the n, which equals to 29.054. So we have 29 full equal payments of $750, and apart the 30th one, or the 30th payment, would be less than $750. Thank you for watching this video. Hope it's useful to you. See you at the next video, inshallah. See you.